All we're doing today is we're going to look at a different form of quadratic functions. We've talked about quadratic functions in vertex form, right? And here's vertex form, which is really convenient for graphing. It's convenient for graphing because just by looking at the function, or we say inspecting the function in math, we could look at the number values for a, h, and k, and we know immediately what are the coordinates of the vertex and what's what's the shape of the parabola. So very, very tailor-made for graphing. Standard form's a little different. This is standard form. So instead of using a, h, and k, this time we're using different numbers. Now a is the same. The a is the same in both forms, but the other two numbers we use in standard form are b and c. B is the coefficient of x and c is the constant. And you might ask yourself, well, why do we have all these different forms? We did this with lines. Why do mathematicians do this? And the reason is because depending on the application or the context, sometimes vertex form is more useful and sometimes standard form is more useful. And the next unit, next section, which is the last section of this unit, we'll talk about how to transition back and forth between the two, which is really not a big deal. Very simple to do. Okay, so a quick review. We already know most of this stuff, right? We've talked about this. We know the graphs of quadratics or U-shaped curves called parabolas. We know that if A is positive, then the parabola opens up and the vertex is a minimum. If A is negative, then the parabola opens down and the vertex is a maximum. We know the vertical line that splits the parabola into two equal halves is called the axis of symmetry. And here's what we know about standard form. Okay, if we want to graph a quadratic function that starts off in standard form, what we really need to do is we really need to calculate the same information that we used in vertex form. We already know what A is, which is going to give us the shape of the parabola, right? Whether it's been stretched or compressed vertically, and maybe it's been reflected, flipped upside down if it's negative. But we need to know the coordinates of the vertex. And to do that, we've got a formula. And you're just going to have to memorize that one. That's a good flashcard formula. If you want flashcards, I can give you as many as you need. That would be not a bad one to just kind of flip through a few times to memorize. We can calculate h with the formula. The value of h is equal to negative b over 2a. Okay, they're real simple. And we're just going to, we're going to get those numbers a, b, and c from standard form. Okay. Once we know what h is the x coordinate of the vertex. Well, how do we find a y value for any function if I have an x value, an input value? Y is the output value. What would I do in any? It doesn't have to be this situation. It could be any situation. If I have a function and I know an input value and I want to calculate the other part of that ordered pair, the output value, what do I always do? What do we do? If I have an input and I want to calculate the output, what do I do? Come on, you guys know this. What do I do? Substitute. Yeah, I just plug it in, right? So the output value k is going to be equal to f of h. It's what I get when I plug the h value into the function. I'm just calculating the output, okay? And that gives me the two coordinates of the vertex, and I can graph this just like I did in the last section, right? The one on vertex form. Okay, so let's just practice a couple of these. And then I'll turn you loose and you can just get some more practice. That's really what this is all about, is just doing math problems and getting practice. So we're starting off with a quadratic functions. Everybody agree that's in standard form, right? Ax squared plus bx plus c. Okay, Abby, what are the values of a, b, and c? Whoops, let's get a different color here. A is 1, good. B is good. Is 80, good job, okay? So those are the values of A, B, and C. Now we want to calculate what are the coordinates of the vertex. Well, let's do the work on this next page where we've got this a little bigger. Okay, so H is equal to negative B over 2A. Okay, Abby already told us that b is negative 18, right? So what's negative b then? Positive 18. Good. Negative b just means the opposite of b, doesn't it? Okay. So we get positive 18. A is 1, so 2 times a is 2. Okay. 18 over 2 is 9. So we know h is 9. Okay, so Arson, how am I going to calculate k then? Well, that tells you right there, I guess, right? F of 9. So I'm going to plug that in. So what's that going to give me if I plug that in? Like just term by term. What's the first term going to become if I plug 9 in for the function? Plug 9 in for x. 81. Okay, I'm going to get 9 squared, which is 81, minus 18 times 9. So we get minus 162 plus 80. And here, why don't we take the two positive ones and add those together and then subtract 162? 81 plus 80 is 161, right? Minus 162. What's 161 minus 162? Negative 1. Okay, so then we've got the ordered pair, HK, which is our vertex, is 9, negative 1. So we can go back to this page here, and sure enough, that's what we got. What's the axis of symmetry? This is just a freebie. If you know the vertex, you know the axis of symmetry every time. Maylin, what's the axis of symmetry then? Babe, somebody remind us, how do we calculate that? What's the formula for the axis of symmetry? It's a vertical line, right? If it's a vertical line, how does the equation have to start out? How do we name a vertical line? X equals, right? It's always going to be x equals. And what's it going to equal? 9, right? We want it to equal the x coordinate of the vertex. We know that because the axis goes right through the vertex, right? Can you make that connection rather than trying to memorize that? Because you'll forget it. Just think about that picture in your mind, right? You know the axis goes through the vertex. A vertical line is named by what all of the x values are in that line, including that one, right? So it's just x equals 9. So we can draw a direct line there, right? We know that's true. And if we're going to graph this thing, then we just have to let's put the vertex on our graph here. So over 9, up 1. Over 9 is right there. Up 1 is right there. There's our vertex. We can go ahead and put our axis of symmetry there if we want to. Right through the vertex. There it is. Okay. And now we want to just graph the shape of this thing. Well, what's A? 1. Okay, so this is a normal parabola, right? It's not calculated at all. It's going to be regular shape of a parent graph. If you want to, you can put this you can make a t-table if you want to. I don't think that's necessary personally, but that's up to you. I'll show you. Negative 9, 1 is our vertex ordered pair. And then I could just pick a value on, really what I could do if I wanted to, is just pick a value on either side of this. You know, like say I could pick like, it's supposed to be positive 9, not negative 9, right? Let's erase that. And then I could pick, for example, 10 and just plug 10 into my function and find out what the output is. And I could get an ordered pair that way if I wanted to. So if I wanted to, all I really need in Desmos, or not Desmos, in Math Excel is 2 points, right? I've got a vertex. I just need another one. Well, I could just pick x equals 10, plug 10 into this function using Desmos, right? I could just go into Desmos, scientific even, doesn't have to be graphing, and write the function down, define the function, and then go down to the next line and do f of 10 if I wanted to, right? We all know that trick, right? Give me 1 to 5 on that trick. We know how to use Desmos to evaluate a function. Okay, right? So we could do that if we wanted to and get my second point that way. That's fine. I think it's preferable personally and faster just to use A, to use the dilation factor. If A is 1, This is a normal shaped parabola. So what is a normal shape of a parabola? If I start at the vertex and I go 1 to the right, what's the height going to be? 1, right? 1 squared, which is 1. So I could, for example, go over 1 and up 1 squared, which is 1. That's fine. That could be my point. And that's all I need is the vertex and one other point, and the graphing tool is going to build the shape of the parabola for me, right? What if I went over 2? I go up 4, don't I? Yeah. I go up 2 squared, which is 4. So I could use that one also. Doesn't make any difference. And if I were graphing this on paper, I could just take those points and reflect them over my axis of symmetry to get free points on the other side. And now all I've got to do is just connect those with a parabola, right? Okay, make sense? Okay, let's keep going. What's the domain of any? Yeah, all reals, right? Because if I zoom out far enough, this parabola is going to go forever to the left and forever to the right. Okay, so we automatically know the domain is always going to be all reals. Melanie, what's the range going to be? That's the set of y values that are graphed on that parabola. Oh, say it again. So it's going to go up to infinity. Where does it start? What's the lowest y value? Is it 2? What's the lowest y value? Positive 1, you mean? Positive 1, right? Because if we look at the coordinates of the vertex, let me just write those in. It's 9, 1. Well, that's telling me what the bottom value of the range is, isn't it? Right? The range for a parabola is always going to start at the vertex. It's either going to go up from the vertex if the parabola opens up, or it's going to go down from the vertex if the parabola opens down, right? So we know that the range is going to go up to infinity from 1. Am I going to put a parenthesis or a bracket on the 1? Bracket, good, because we're going to include the 1. Very good. Okay. Oh, but it should be, oh, you're right, it was negative 1. I put this in the wrong spot, didn't I? Oh, how am I going to fix that? I think if I do this, I think I can move that whole thing. Oh, look at that. That's pretty slick. All right. So let me make some changes. That was supposed to be negative 1. Okay, there we go. Much better. Okay. Okay, good. And then down here at the bottom, I just included, like if you wanted to, just to demonstrate something, here's in Desmos. Remember, that's how we can evaluate a function. Enter the function, go down to the next row, and then just do like f of whatever number I want to input. It gives me the output, okay? All right, let's try another one. How about this guy? How about this guy? So here's our function. Okay, I got to find the vertex. I already know the value of A, don't I? Well, what are the values of A, B, and C? What's A, everybody? It's in standard form, right? What do we get? Miranda, what's A? Negative 2. What's B? Negative 12. And what's C? Negative 10. Okay. So then H, what's our formula? Stay with you here, Miranda. See if you can remember. What's our formula for H? There you go. Negative B over 2A. Good. Okay, so if I plug in the values here then, negative B is what? B is negative 12. So what's negative B? 12. Okay. And Abby, what do I get on the bottom? What's 2A? Close. A is negative 2. So what's 2A then? Negative 4. 12 divided by negative 4 is negative 3, isn't it? So we get H is negative 3 to SA. How am I going to calculate K? If I know H is negative 3, How am I going to calculate k for this function? You told me this before, I think. Okay, remember, all I have to do, k is just going to be equal to f of h, right? K is simply going to be the output when I input h. So k is going to be f of -3, right? Well, what do I get if I plug that in? Every place I have an x up here, I'm going to replace it with the quantity -3. Okay, now going back to, I think this was test, I can't remember if this was test, I think it was test 2. God, I think it was test 2. Might have been test 3, actually. One mistake that people sometimes made here was they wanted to multiply the -2 times the -3 before squaring. Is that correct? Well, must not be. I said it's a mistake. What should I do? Got to square first. When I use PEMDAS, I have to do exponents before multiplying. So -3 squared is +9. -12 times -3 is 36. So what's that going to give me? 36 minus 18 is 18, minus 10 is 8, right? So I get a is equal to -2, and my vertex has coordinates. H is -3, k is 8. Okay? So we can go back over here, and there's our vertex. We said, what's the, okay, so we could put that on our graph. -3, +8 puts us, -3, +8 is right there. Okay, what is the equation? Malin, I'm coming back to you on this one. What's the equation of the axis of symmetry then? X equals, you're right, -3. You got it, perfect. X equals -3, and we get that from here, don't we? There's that connection. Good. So we could write our axis of symmetry then, or draw our axis of symmetry right there. We'll need that later. And now we have an option, right? Here is where we could either just input a value like -2 into my function to get another point, or we could use the value of a, the vertical dilation factor, right? So I could, if I wanted to, I could do something like this. I could type in f of x equals blah, 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 whatever my function was, calculate f of -2, and I get 6, right? I get the point. Input -2, output 6. So I could just do this, right? To get a point at -2, +6 right there. That's one way to do it, okay? What if I use the vertical dilation factor? That's what I prefer. That means we're going to multiply the parent height by a. Well, you've already told me if I go over 1, I go up 1. That would be the parent height of the function, right? If I were going to create my parent graph, that's what it would look like. I'm going to multiply the height of 1 times a, which we already established was -2, right? And what do we get? Okay, well, that's an easy one to do. +1 times -2 equals -2. So that's going to be, so that's the height of the dilated graph. Give me 1 to 5 on that. Does that make sense? Okay, we've done a few of those, right? We're getting there. Okay, getting there. All right, so that's the other way we could get that point. And again, if I'm graphing this on graph paper, I would just reflect that over and make a reflected point on the other side. And now I'm just going to connect all those with parabola and we're done. Okay. All right, real quick, and this will be it for today. What's the domain of any parabola, everybody? All reals. Okay, what's the range going to be on this one, Melanie? And let's remember the ordered pair of the vertex here is -3, 8, and the parabola opens down. So the range is the set of y values, discrete values. Okay, 8. Well, if I did 8 to infinity, that would mean it's going up. Is the parabola going up or down? Okay, so -infinity to 8 with brackets.